Techs in Global School. Operations with algebraic expressions. Multiplication. There are three general cases to perform products between algebraic expressions: monomial by a monomial, monomial by a polynomial, and polynomial by a polynomial. It is essential to have the laws of exponents analyzed in previous classes to perform these types of operations. On the other hand, we will remember the rules of the signs of multiplication. Plus times plus equals plus, plus times minus is minus, minus times plus gives minus, and minus times minus is plus. In summary, the product of equal signs is positive, the product of different signs is negative. We will then start with the first monomial by a monomial case. These types of expressions are performed and simplified using the laws of exponents. Let us look at some initial examples. The product 3a times 2a is performed by grouping real numbers and variable factors with equal bases. Since the bases of the real numbers are different, we simply perform the product of 3 by 2, thus obtaining 6. The product between equal bases is carried out using the laws of exponents. So, since both bases a are raised to the first power, we add their exponents, thus obtaining a result of 6a squared. In the second example of a monomial by a monomial, we will do the same. We group the real numbers and those factors with equal bases. We apply again the laws to add the exponents of equal bases. The real numbers have equal bases, so they can be simplified by using the laws of exponents. Hence, simplifying the bases, we get 5 cubed times x to the fourth power times y to the fifth. Expanding the cube of 5, we get 125x to the fourth, y to the fifth. In this next example, we can see a monomial squared, which, by definition, can be represented as the product between two monomials with the same factors. We group real numbers and factors with equal bases. Using the laws of exponents, we represent those bases without an exponent as the base raised to the first power, and we simplify by adding exponents with equal bases, thus obtaining 7 squared, a to the sixth power, b squared, c to the 10th power. We develop the square of 7, thus obtaining 49a to the sixth, b squared, c to the 10th power. In the following example, we will begin to perform the process according to the order of operations. Recall that the order of operations establishes first solving exponents, including radicals, then multiplications and divisions, and finally, additions and subtractions. Therefore, we will develop the exponents first. Using the laws of exponents, we multiply the exponents of each base by 2 since it is squared. We will also represent those bases raised to the first power to facilitate the execution of the operation. Once the power has been simplified, we proceed to perform the product between the remaining monomials. We group factors with equal bases. Later, we add exponents of those equal bases to simplify. Developing the product of real numbers and equal bases, we obtain a result of 12x cubed, y to the 7th power, c to the 4th. In this other example, the product of two algebraic expressions is shown. We can see that the squared factor is not a polynomial. Since it does not meet the definition seen in previous classes, one of its literal factors contains a radical. However, the process is the same. Laws of radicals are included to perform the operation. We prepare the expression by transforming radical factors to factors with bases with fractional exponents. We will also represent those bases raised to the first power. Then, by order of operations, we will perform the exponents. Then we will group real factors and factors with equal bases to add exponents and simplify. Remember that the results of operations must be represented with positive exponents and radicals. In this case, we will transform those bases with fractional exponents to radicals. The result is 4/9 of cubic x, y to the 11th power, times the cube root of z raised to the 8th power. We will then go on to the second case of multiplication, monomial by a polynomial. We will also use the laws of exponents and the distributive law to perform these types of operations. Recall that the distributive law indicates that the product between a real number and the sum of real numbers is equivalent to the sum of the products of each addend by that number. Let's look at a first example. We perform the operation of a monomial by a polynomial. As we can see, we apply the distributive law to perform the operation. We will multiply 3a by each term of the polynomial. Remember that 3a is positive, so when performing the product of this monomial for each term of the polynomial, the signs do not change. Applying the distributive law, we have in each term a product of monomial by monomial. Each one is simplified by applying the laws of exponents. We group real numbers and literal factors with the same base. Then, we add exponents of equal bases to simplify. In this way, we obtain as a result of this product minus 3 cubed square minus 3a. We can see that the result is expressed with positive exponents and sorted in descending order. We will perform the operation of a monomial by a polynomial. In this case, the variables of the terms are alphabetically disordered. It is recommended to sort them first to facilitate the process. Subsequently, we apply the distributive law of multiplication considering that the signs will change since the monomial is negative. We then simplify each term as a product of a monomial by a monomial using the laws of exponents, thus obtaining minus 15x squared, y to the 5th power, z to the 5th, plus 5x y cubed z cubed minus 10x squared y squared z cubed plus 35x y z squared. We can see that the result has positive exponents, but we have to sort it in descending order as shown. We analyze a last example of this case. The first factor of this operation is not a monomial, since it does not meet the definition seen in previous classes. That is, one of its literal factors contains a radical. However, we perform the same procedure for the operation. We sort the literals of each expression alphabetically and represent radicals as factors with fractional exponents. Then, apply the distributive law of the multiplication with each term of the polynomial. We simplify each term as a product using the laws of exponents and radicals. In this case, we obtain the result of the operation sorted in descending order. The last product case between algebraic expressions is polynomial by a polynomial. An algorithm to perform the product between polynomials is done by sorting the polynomials in descending order. Then, the polynomials are arranged in two lines where the multiplicand and the multiplier are identified. Subsequently, we multiply each term of the multiplier by each term of the multiplicand. So, we arrange each product according to the corresponding column so that the addition is easier. Finally, like terms are added, thus obtaining a descending ordered result. Let's look at a first example. We will perform the requested multiplication between polynomials. According to the algorithm, sort the polynomials in descending order. Later, we arrange the polynomials in two rows. In this way, you can identify the multiplicand and the multiplier. It is important to highlight that the terms are arranged according to the corresponding column. That is, the independent terms will be one column, the linear terms another column, the quadratic terms another column, and so on. We then multiply each term of the multiplier by each term of the multiplicand. We arrange each product according to the corresponding column so that the addition of like terms is easier. In this way, we obtain a descending ordered result of 3a raised to the 4th power plus 11a cubed plus 24a squared plus 41a plus 5. In this last example, we repeat the algorithm. First, sort the polynomials in descending order. Note that in this case, a term is missing from the multiplier, so it is recommended to represent it as 0, in this case 0x. This point is important since if this detail is omitted, the order can be lost, making the process difficult. We then arrange the polynomials in two lines and multiply the terms of the multiplier by the multiplicand. We then add like terms according to the columns and thus obtain a result of x to the 6th power minus 6x to the 5th plus 8x to the 4th minus 2x cubed minus 13x squared plus 9x minus 6. The product between polynomials can also be obtained by multiplying term by term. Later, like terms are identified and simplified. However, it is important to be careful when simplifying like terms in this way, as they are not directly ordered. It is suggested to use colors when reducing like terms to avoid mistakes. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com